Welcome to the second part of my kaleidoscope example. In this example, what I'm going to do is handle the problem of how we rotate and reflect these little triangles around on the canvas to create the kaleidoscope effect. In the last video, I drew this diagram where I showed how the cells get reflected and rotated, and it's quite complicated. You can see here I've been kind of sketching on this afterwards to sort of figure it out for myself. And what I figured out is that each time if I have a cell like this, if I go to the next one, it's kind of like I rotate it, but not just rotate it, also flip it over, reflect it. So each time I go one around, I rotate it and then flip it over. And you can also see it works this way as well. If I move from this cell to this one, I rotate it around and flip it over. So each time around, it's sort of reflecting and rotating. So even numbered kind of rotations are like a forwards R, and odd numbered ones are a backwards R. Let's start by creating a function that's going to do this work for us. It's quite a lot to think about, so doing this all in the main draw loop is going to get messy quickly, so a function will be really helpful for us here. And I'm going to call the function kcell for kaleidoscope cell. And it's going to take three arguments: an image, a whether to reflect or not, and the number of rotations that we want it to do. And for a start, I'm just going to kind of create a rectangle the same size as the image and just fill it with a dark grey color and return that. So let G equals create graphics image.width, image.height, and then G.background 20, and then return G. So it's returning a graphics object, so then we can use that in the main draw function, just like we would draw any other image to the screen. So I can actually say here, image k cell, and I need to pass in those arguments. So the image is going to be my pebbles image. And I'll just put false and 0 for the other arguments for now. We're not actually using those arguments, but we will soon. And I'm going to draw that at 10 from the left and 100 from the top. There it is. We've got the grey cell, and it's the same size, you can see, as the original image was. Now let's actually draw that image into the graphics object and return it. So before I say return G, what I want to do is say G.image img. And I'll just put that at the top left corner. So there you can see the image has been passed in, we've created a new graphics object, pasted it into that, and then returned it and drawn it to the canvas. Now, our lives are going to be a lot easier if we set the image mode on this graphics object to be image mode center, and because when we're doing rotations and things like that, rotating from the center is a lot easier. So let me get that working. I'm going to say G.image mode center, and then G.translate and then draw the image. So nothing should change, it looks exactly the same, but now we're drawing that image with the center of the image as the XY position. All right, let's start by trying to reflect this image. And I'm going to reflect it sort of across the vertical axis. So to see this working, I'm going to add another image to my canvas here, and I'm just going to call that same kcell function but with different arguments, and it's going to give me a different result that I can draw to the canvas. So I'm just going to change false to true. And then we want to use that in the drawing function. So I'm going to say here G.scale -1, 1, And I only want to do that if the reflect argument is true. So if reflect, then scale it in this way. And that will have the effect of flipping it left to right. And actually, I want to just draw this at a slightly different position. So I'll put this at 160. Oh, I can put it at 110, I think. Try 120, just so there's a bit of space there. So there it is. It's flipping the R from left to right. So we're on our way with the reflections. Now let's start looking at rotations. It shouldn't be too hard, but there are some tricky parts to this, which you'll see in a second. So I've got those two. Now I'm going to just copy those two lines and just change it so that instead of putting 0 in for the number of rotations, I'm going to put in 1. So we do our first rotation. 1 and 1. And I'm going to draw these at 230 and 340. Whoops. 340. Okay, so nothing's happening yet because I haven't used the number of rotations. In order to use that, I need to rotate before I draw the image. So here I'm going to say g.rotate. Radians, rotations times 60. And here's where we run into our first problem. So you can see it has rotated, but it's sort of pushed down a little bit, and then it's also slightly off the screen, like the edges of the triangles have gone off the screen. So let's do another couple of rotations and see if there's a pattern in how these problems are happening. So I'm going to copy that, and I'm going to do another line below it. So these are going to be at 200 pixels down from the top. And I'm going to make these 2 rotations and 3 rotations. And I'm going to do the same thing again for the 4 rotations and 5 rotations. This is all of the different combinations of rotations and reflections that we need for the kaleidoscope. Okay, so you can sort of see that the first 2 are kind of fine. The second 2 on the top line are pushed down and they're off the screen. The third 2 are kind of pushed up, and the fourth 2 look fine. The fifth 2 are pushed up, and then the sixth 2 are pushed down. Let's think about what's going on here. Part of the problem is that when we're rotating around a square, we're rotating around the center of the rectangle. It's actually a different point to the center of the triangle. So if you sort of imagine this triangle here, and it's sitting on here with its center is actually slightly below the square's center. And if I rotate it from somewhere up above, when it rotates, it actually moves off the side of the square. That's why it's getting pushed off to the side. So what we want to do is not just translate straight to the center of the square. We want to translate to the center of the square and down a little bit. We want to know what this length here at C is, or B or A. These 3 numbers are what we want to figure out. Basically, that tells us where the center of the triangle is. We're going to need those to figure out how to do the rotations properly. How do we figure them out? Well, actually, we could just use some trigonometry again, a bit similar to the first example, except here, if I draw a line from the edge of the triangle into that center point, that's going to be 30 degrees. And then I know this length is 50. It's half of the overall width. So this length A is going to be 50 times the tangent of 30. I just need that little formula, and once I've got A, I can figure out all of the rest because I know what the overall height is. So let's do that. Let's figure out A and B and C, and then we'll use them in the sketch. So I'm going to say, let's get rid of these extra lines here. let A equals 50 times tan of radians 30. And B is going to be the overall height, so image.height minus A. And C is going to be A minus image.height over 2. So I'll let you think about that, and you can just sort of have a look at that drawing again. A is equal to the overall image. A is equal to that tan 30 times 50 that we figured out. B is equal to the overall image height minus A. And C is equal to A. C is actually equal to B minus image height over 2. So I had a little mistake there. I think C is equal to B minus image.height over 2. So where we need to use these is when we translate first. Rather than translating by height over 2, we want to translate by A instead. Actually by B instead. We want to move down a little bit further. The other thing that we need to take into account though is when we rotate, we've still got image mode center, so we need to, when we draw the image, we need to kind of offset it by negative C. So when I actually draw the image, I just want to put in, I think it's negative C, it might be positive C, we'll soon find out. I think that's looking right. There's still one problem though. You can see the third and fourth columns, they're all sort of pushed down. And this is like another reason, this is also because of the difference between the geometry of the triangle compared to this rectangle that it's contained in. It's really too boring and uninteresting. You could figure it out for yourself if you're interested. It took me ages to figure this out, but my fix is just to check if we've got an odd number of rotations, and if we've got an odd number of rotations, just move it up by an amount to counteract that. So what I'm going to say is if rotations modulo 2 is equal to 0, is equal to 1, so for every odd numbered rotation, I'm going to move it up by a little bit. And it's going to be I'm not sure if that's correct. I figured it out before, and no, it's not. That's not right. That's not right. Okay. First problem is I need to say g.translate. Whenever you're working on these graphics objects, you need to prefix all of your functions with the name of the object. So g dot. Yeah, indeed, that is working. Okay, so we've got all of the different rotations and reflections that we need. I'm just going to move these down the page a little bit so that they just look a bit better on the page. That's where I'm probably going to leave this video. And in the next one, I'll come back and look at how we then sort of take these, put all of these together and then put them together into a grid to get the kaleidoscope effect. Just one last thing I could do is, I'm not going to want to have this black background on the triangles when I put them together, because then they'll be overlapping in funny ways. So I can actually just comment out that background line and it comes out transparent. All right, happy creative coding. Look forward to seeing you in the next video. And look forward to seeing what you come up with based on this example. Thanks very much.